Hello, everyone, and welcome to this episode of Kafka. Today's lecture, we are going to cover basic fundamental elements that make up Kafka. This lecture doesn't have any actual code, Java code, or any code, but before we start coding, we do need to understand the fundamentals or what is that makes up that software component system. So in the next lecture, we'll have the actual coding implementations, the API implementations, but let's first understand what is actually Kafka. This is how a Kafka architecture looks like. The end goal is to let the messages from the producer reach the consumers. That's the end goal. And in between whatever happens, or that is the Kafka way of doing it, the speciality of doing it. That's where its architecture comes into play, so that we ensure that the messages are delivered to the consumers promptly, efficiently, without losing it, and in the order in which it was received, or based upon the configuration. So let's see the different components, all right, in action. So basically, see, the end goal that Kafka is trying to achieve is the messages from producers reach somehow to the consumers. So let's go ahead. Let's see what are the different components. What is Kafka basically? It's an event streaming platform. What is an event basically? It is nothing but a fact, something that happened in your system, or it's any type of action or incident, anything that is there. For examples, a payment made in a banking system, let's say a withdrawal, a deposit, right? For credit cards, a transaction made. For e-commerce system, an order placed. Anything that has happened. Now, important thing to note is that it's immutable. You cannot go back and change that event because it is a fact of what has happened in the past. So it cannot be changed. That is an event. Now, what is a topic? In software analogy, you could compare topics being similar to a database table, right? So let's say in a database, you'll have table related to orders, you'll have table related to users, clients. Each table represents an entity, right, in databases. Same way in Kafka, each topics represents a category. So say, for example, orders placed, again, like whatever the event is, orders placed, again, users subscribed, anything, that's a topic. So it's an abstraction you probably think about the most. You can have different topics to hold different kinds of events. Okay, you could filter them, transform them, and work on them. A topic is nothing but a log of events, right? As we said, as orders. So orders happened in time. Okay, today, tomorrow. So it's a log of events. Okay. When you write a new message into a log, it always goes to the end. So when a new message is published or new message is sent, it's a log means it's an entry, like a queue. The new message will go in the end. Secondly, they can only be read by seeking an arbitrary offset, which means from a certain point. Offset is nothing but a marker. And then from then onwards, go in sequential. And third, events in the logs are immutable, as we once said, because this is something that has happened in the past. And we don't have the time machine to go back in time and change our past. So whatever has happened, okay? So events are immutable. So again, Kafka is an event streaming platform. Events are nothing but facts that have happened. Topics are nothing but categories or logs in which event can be categorized. Partitioning. Now, one event can be distributed into different partitions. Because see, it's a log, right? So what happens is, if some customer or somebody starts sending millions and millions of messages, you're going to fill up the system. Okay, you're going to fill up the queue pretty fast. So what Kafka does it partitions the messages. It creates partitions. Now each partition, so whenever the message comes, if the message has a key, Kafka will compute the hash of the key, apply some algorithm, and send it to the specific partition. If the message coming in does not have a key, then the load balancer will distribute, the broker or the load balancer will distribute the messages in round robin fashion in different partitions. Okay? So partitioning takes a single topic, breaks it into multiple logs. Each log can live on a separate node in Kafka. Okay, just like Kubernetes has multiple nodes, each partition can be in a different node. Okay, and if the message, as I said, does not have a key, the messages are distributed round robin, and all partitions can get even share of data. But one thing to note is, in this scenario, we cannot guarantee the ordering because we don't know in which order the events were received. They are just distributed randomly in the order, in the round robin, right? But if the message has a key, it is hashed and always sent to the same partition, and therefore we can guarantee the order. Okay. Kafka brokers. What are brokers in Kafka? They are the actual physical machines. Okay, network of machines. Rather, it's not just one machine. Nowadays, when we are talking about distributed systems, we never talk about one machine. There are different machines, and the collection of them are called as brokers. They could be physical servers, or they could be virtual machines running on pods. They could be anything, or somewhere in the physical data center, anywhere. But they are machines running the Kafka broker processes. Okay. What do? Each broker hosts some set of partitions or handles them, some set of partitions, okay, so that you can write events to those partitions or read from them. Brokers also handle replication of partitions between each other. Okay, now we're going to study replications. Okay, so brokers are physical machines or virtual machines which run the broker process, Kafka broker. What is replication? Replication is not unique to Kafka. Replication means whatever you have that in one machine, you replicate in others. Now, this is a failover mechanism used by every distributed system or even in-house, right? If you have a database, you always have it replicated somewhere so that if the original server goes down, you always have something else to fall back on. So that's replication. What are Kafka producers? Now we are coming to the producer and consumer, right? Producers are the systems that generate the events. They are the API. Kafka provides producer API, okay? The Kafka producer API that you will use. It's nothing but a key value pair, a producer record. Key value pair means record is nothing but the event. Okay, this is how you represent. This is the class which you use to represent the event. Key is the message key. Value is the actual content of the message. This key will be used by Kafka to compute the hash of the message and decide which partition this message should be sent. Okay. So we'll be seeing actual demo of Kafka Producer API, Consumer API, and how to use it. Kafka Consumers. One more thing. This API is so simple. It will expose certain methods, send message, okay, to the Kafka system. That's all it would be. A producer record, send it. But it seems very simple, but underneath the covers, it's managing the connection pools, network buffering, waiting for the acknowledged messages, retransmitting in case of failures. A lot of things goes on under the hood, which a developer need not concern with. Okay. Last concept for today is consumers. They are nothing but the subscribers. So they could be a different component of the same application, or they could be entirely different applications, whoever is subscribed to the messages. Okay. And they can decide, the consumer API can decide what to do with the event or how to process the event. So let's say an order received. So the consumer of the order received event will then trigger different mechanisms, okay? A chain of actions. See, send it to the warehouse, give the address, give it to the sales team, accounts, everything, right? This is just an example, okay? So again, Kafka exposes consumer API. The consumer connects to the cluster, and depending upon which topic it is subscribed to, okay, reads the messages that are available on those topics. Now, the publisher API produces the producer record. Consumer API has a consumer record object. Okay, it represents a key value pair of a single Kafka message. So one instance of producer record is one message that the producer sends, or one event. Consumer record, one instance of consumer record is one instance of the event or the message that the producer needs to consume. Okay? So in today's lecture, these are some of the topics, fundamentals that I wanted to cover before we jump into using the API, because it's important for you to know what is partition or how a message is distributed, so that you can decide what should be the key to for the message, or whether the message needs any key or not. Okay, so this is all about Kafka. See you all again in the next lecture. All right, thank you.